So planning experiment. So we did about the lens. I remember the last. Question 11 will do, or question 10 is about the pendulum, the time period of pendulum. You will find a repetition in like a very common type of question. So question 11, a student has a selection of a rubber bands of different widths. So student is having the rubber band and it's of different widths. He is investigating the extension produced by adding loads. Figure 4.1 shows a setup. So we have a boss, a clamp, a stand, rubber band, a hook is attached to the other end of a rubber band, and we have the bench. Means it's placed in this manner. Like if this is a bench, the rubber band is placed on this side. So we can add a load and it can stretch easily. So in addition to the apparatus shown in figure 4.1, the following apparatus is available. A meter rule, a meter scale is there, a selection of different rubber bands, selection of loads, different masses are there. Plan an experiment to investigate how the strip of a rubber of different widths, when loaded, like experiment to investigate how the strip of a rubber of different width stretch when loaded. Like when we add load or when we add the mass to these different widths of rubber band, how it stretches. That's the investigation. So the first part, explain how would you carry out the investigation. So first thing, what we will do, we will set up the apparatus as shown. So we'll set up the apparatus as shown, as you can see, like this figure is there. So after setting the apparatus, we will measure the length of unloaded rubber band and that length usually that is called L naught or L0. Then we will add load and measure the new length. You will mention the apparatus as I mentioned, try to maximize by mentioning, like measure the length of unloaded spring by L naught by a meter rule or a meter scale. Then we will add a load and measure the new length. The new length we call L. Then calculate extension. How we calculate the extension? Extension is the loaded minus the unloaded. That will give us extension. So calculate extension, which is E, by using a formula that is a loaded length of a loaded rubber band minus the length of unloaded. Then we will add 5 different loads and we will repeat the procedure. As I mentioned, whenever you mention the procedure, you should mention in a procedure, you should always include the sources of errors and the precautions you will take. So what are the sources of error? We should And another thing, because we are investigating how the width is affecting the load, the stretching. So we will repeat the experiment with 5 different or 3 different rubber bands. The next is uh, like the procedure, like in the precaution related to this. So we should avoid a parallel, because a measurement is there. So we should avoid a parallax error, look perpendicular. Then, because when you add a load, the rubber band or a spring usually vibrate. Yeah, that is about the key variable. But right now we are mentioning key variable is the second bullet point. But first we are answering how we carry out this investigation. So we should avoid a parallax error, and we should place the load gently or attach the load gently, and we will measure the length when the spring, sorry, not spring, actually it is valid for spring also, when the rubber band stop vibrating or oscillating. So this is a procedure. The next is, so that we did about the procedure. State key variable that you would control. What are the variables we will control for this experiment? The key variables we should control. Type of a rubber band, yes. The material of a rubber band, that's right. Initial length, that's right, correct, Imad. The length, the initial length, or you can say the original length, should be same. What else? The material of the rubber band should be same. The set of loads which are used, yeah, the height from which it is clamped, that is like the place or the position where we connect a hook, that should also be same. The material of the rubber band should be same. The set of loads which we use, that should also be same. So state key variables done. Then draw a table or the tables with a column heading. So what is the table or the tables? So we are measuring L, because L naught is measured one time. So we don't need a column for that, because L naught is the original length. We'll measure one time. L is what we are measuring, and then we are calculating extension. And the load is there. So usually, like if your load is capital L and length, you can use a small l. So you can distinguish between them. Yeah. If like capital L, I will example I'm using here. I mean to make a small L, but I was typing, that's why. So here, this was load and Newton. Then length is there, L in centimeter, and then extension is there in centimeter as well. And because different materials are there, so you can say this is for material or for rubber band A, and then the same table you can draw for material B as well. So load, length, extension, and then that is material B. How would you use your readings to reach a conclusion? So again, what we will do, we'll plot a graph. Here we are changing the load and extension changes. So load is independent and extension is dependent. So we can plot a graph between load and extension, and we can compare the gradients. But remember, for extension and load graph, the slope is reciprocal of K. Like the one which gets steeper means it will have a smaller value of a K, and smaller value of a K means it will be easy to stretch. And we can also mention a point because we are investigating how different widths are. So we can, using a meter rule or a meter scale, we can measure the width of these rubber bands. Is it clear, this whole experiment? The marking scheme points, as you can see here, the answers are there at the end of each question. So measuring a length of a band, hang a load and measure the new length, we did. Repeat with different thickness, we did. Same original length should be there every time, control variable. And the table with a column heading like thickness, length, extension with unit. Because thickness is, we are investigating how the thickness, that's why I mentioned the thickness will be there. Or load and length extension with unit can be there. Then plot a graph. You can plot a graph between extension and length against the thickness, or you can plot a graph between extension and length, or compare the extension and length for different, how it is affected. Yeah, because we were investigating how the thickness, so it should be, thickness should be one variable. Then we should use the same set of loads, or we should at least 5 different thickness, as you can see, and show how extension is calculated, and same type of material or material of a rubber band should also be same. Is it clear, this experiment?